Hello, and in this video we're going to look at how to calculate the variance and the standard deviation for a group of scores by hand. Now, these are very basic skills and given to you by any statistical package by running the descriptive statistic command. So you might think you don't need to know how to calculate these, but in the future I'm going to be doing videos on how to manually calculate lots of statistical tests, and both these measures are the basis for a lot of significance testing. So I'm doing this video as sort of a foundation for those other videos. So we're going to look at how to calculate variance and standard deviation. First of all, what are the variance and standard deviation? Well, they're measures of dispersion, measures of how widely spread out some data points are. In order to work this out, as you'll see later, we have to square a lot of values. So the difference between the variance and the standard deviation is that the variance is expressed in squared units, but the standard deviation is expressed in the units that we initially measured the variable, so it's more intuitively interpretable. So if we go on and look at our example, we can see we've got five scores here: 5.3, 6.8, 8.93, 7.1, and 11.52, and we can get some kind of basic sense that those figures aren't very spread out. They're all pretty similar, but that's just kind of an intuitive sense. We need some way to quantify it. So that's what the variance and standard deviation are. We're going to look at the variance first, because in calculating the variance we also go a long way towards calculating the standard deviation. So we're going to move the scores to one side, because the first thing we need to do is calculate the mean of these scores. So that's just like any mean of any scores. So as this equation shows, what we're going to do is we're going to add up all the scores and divide by the number of scores that we have. So after doing that, we get a mean of 7.932. Remember that number; it's very important. It's on the next slide. But yeah. So now what we want to do is we've got our raw scores and the mean. What we want to do is work out the raw deviation, how much each score deviates from the mean. So I'm just going to demonstrate with the first one. So if you want to know how far away 5.3 is from the mean, what we need to do is take the mean, so 7.92 away from 5.3, and that'll give us a sense in terms of the raw score of how much each score deviates from the mean. So if we look at that, for the first score, 5.3, we get a raw deviation of minus 2.32, and we need to calculate that for all of our scores. So we've worked out our mean. So we're gonna do 6.8 minus 7.932, 8.93 minus 7.932, 7.1 minus 7.932, and so on for however many scores we have. And we're going to record that in another column like this. So we've now got our raw scores and our deviations. This gives us again some sense of how spread out the scores are, but it's not a standardized measure. We can't get an overall summary of overall how spread out are our scores. This is in the context of the individual scores. So to calculate the variance, the next thing we need to do is square those deviation scores, and the reason why we do that is what we're going to do for the variance is essentially work out an average deviation. But obviously, as we just saw, to work out a mean, we know that we add up all the scores, and if some scores have pluses and some scores have minuses, they're going to cancel each other out. So we need to square the deviations to get rid of any minuses. So if we move that over and look at the equation, if we take our first one for example, we can see that the first one had a deviation from the mean of minus 2.632, and if we square that, just square on a calculator, we get 6.927. And likewise we're going to do minus 1.132 squared and record that. Once we've got all our squared deviations, we should get something like this for this data. So how do we actually calculate the variance? Well, the first thing we're going to do is work out the sum of all these squared deviations. Overall, how much variability or how much spread is there in our data? And when we add up all those scores, we get an answer of 22.863. Now, this gives us some sense, but I said the variance is essentially an average, how much on average each score deviates from the mean. So this isn't an average. This is the total amount of deviation. So just like any average, to get the variance, what we're going to do is take our sum of squared deviations and divide it by one less than the number of people we've got. And you remember we had 5 scores. Now, why do we divide by one less than the number of people we got? It's a very slippery concept in statistics called degrees of freedom, but basically because we used the mean in calculating all those squared deviations, we've already eaten up, well, essentially one person worth of data because we've estimated one thing. So to calculate the variance, we want to do the total squared deviations from the mean divided by one less than the number of scores we've got, and you see we get 5.716. I want to point out that you can see how I've rounded up a little bit. We've got 22.863 for the sum of squares, but if we go back, our square deviations are a lot more a lot of kind of have more decimal places than that. I just shortened it for the sake of this equation, but we get a mean from that now, a variance now, because I shortened that. Obviously, we have far less precision in this estimate of the variance. So if you calculate variance on a statistical package on these data, you'll get a slightly different answer, but it's just rounding error. So we've got a sense of the variance, and that's how much in squared units the average deviation from the mean. But we probably don't want it in squared units. We probably want it in the units of our original scale. So that's what the standard deviation is about. And to get the standard deviation, all we're going to do is take the square root of the variance, which in this case is 2.27. So overall, what that's told us is there's not much dispersion in the data, but it's given us a kind of numerical way to express that. So a good takeaway from this video is often people just want to calculate standard deviation from the data, but you have to calculate the variance first and then square root the variance to get back to the individual units. So the process basically is calculate a sum of squares, which is the amount that each score deviates from the mean. Divide that sum of squares by the sample size minus 1, and that will give you the variance. And to get the standard deviation, square root that. So thank you for watching this video, and I hope you found it useful. Bye bye.